Recording. Turning subtitles on. Let's turn that off. Let's turn subtitles off. Okay. Okay, just to confirm, everyone can still see this, right?
Yeah.
Everybody else?
Yeah, I can see it.
I can see it.
I can see it.
Done. Let's do it then. So we're starting with trig. We'll do some of the 2-unit trig first, and then we'll move on to the 3-unit trig. I'm going to probably skip some of the easier stuff, the easier stuff being just going through sine rule, cosine rule, because, I mean, you've done it last year, and because once I actually do this with the advanced kids, I'll send the video across to you guys, and you guys can just straight watch that, and if you've got any questions, we can go through that. But being extension students, usually the sine rule, cosine rule, etc., is really straightforward. There's nothing to it. All right, first thing we need to learn are these exact trig ratios. Now, you would have learnt these last year, but you would have learnt them most likely through a triangle. Now, that is not the way we're going to learn it, and it's not the way I usually teach this. So the way we are going to learn it is either you're going to memorize what each one becomes, which tends to be a little bit difficult for some students, or the other way is to use a little trick that I created a few years ago. So, do we all have our calculators handy?
Yeah.
Yep.
Perfect.
Yeah.
So we're going to do this together. So the first one, A, sine 30. Plug it into your calculator, and it should say half or 1/2 as a fraction. So that's already exact, and that's perfectly fine. Any questions there? Great. Next one is cos 30. Plug that into your calculator. What does it say? 0.866 and goes on forever. So it's not exact, right? What we're going to do now is we're going to square this term. So square it. This is my trick. We're going to square it. You should see 0.75. Press the SD button so you can see 3/4, and then you mentally square root this. So now mentally square root. So you're not allowed to just go and square this, obviously, that's not really allowed. So what we've got to do, we've got to square root it, but if we just square root this term on our calculator, well, we're just going to return back to this answer. So that's a bit useless. What we're going to do is mentally do it. So the mental square root of 3 is still root 3. Mental square root of 4 would become 2. And that's the answer we want. Now, I know that usually confuses some students, so please let me know if you want me to explain that one more time. Is everybody happy with that?
Yeah.
Yeah.
Okay. All right, done. Fair enough. Let's do tan 30. Andy, you can do this one, me and you together. So tan 30. Plug it into your calculator. What does it become?
0.577.
Done. And then what do we do now?
Square it.
Square it. What do you see in your calculator?
0.333.
Press SD. What do you see now? 1/3.
Yeah.
And then you're not allowed to go and square it, so you're meant to square root it, which becomes 1 on.
Root 3.
And that's the answer to tan 30 in exact form. Yep. Any questions?
No.
All right, wait. Shania, your turn. We're going to do B together.
Okay.
Sine 60, plug it into your calculator.
That's 0.866.
Square it.
That's 3/4. And that would be 3√3/2.
Beautiful. Cos 60, plug it into your calculator. What does it say straight away?
Half.
Done. So that you don't need to do anything to. It's just the ones that are not exact values, right? So that one we had
Yeah.
to. This one is easy. Tan 60.
1.732.
Square it.
3.
So then your answer is
√3.
amazing, right?
Yeah.
All right. Emily, any questions, Shania, firstly?
No.
No.
Thank you.
All right, Emily, we're going to do E together.
Sine 120 is 0.86, but then when you square it, it's 0.75, which then is 3/√2.
No, square root. Did you say square root?
Yeah, square root 3/2, I meant, sorry.
Yep, that's fine. All right,
Cos 120 is negative 0.5.
so that just becomes negative half.
Yeah.
And then?
And then tan 120
Okay.
is negative 1.5. When you square it, it becomes 3.
Wait. Just go back one step. So tan 120 was negative 1.73, right?
3. Yeah.
Okay.
And
now
then when you
square it.
it becomes square root 3.
Yeah. But let's learn something here. Now, I created this trick, right? I created this because a lot of students were struggling when I first started teaching how to actually memorize the triangle, firstly. And then secondly, when it's not a triangle like these numbers here, when you can't use these triangles, how this whole thing works. So I created this trick. Now, unfortunately, it's not flawless. So there are cases like this where you can see that you've got a negative, but of course, when you square a negative, it's always going to become a positive anyways, right? So what you've got to remember is that if it started off as a negative, this answer must still be a negative as well. Does that make sense?
Yeah.
Emily?
Yeah, it makes sense.
Yeah. So just be careful. It's always going to become positive when you square it, but you got to just work out if it's negative originally, then the actual answer should still be negative. All right, Anouk, we're going to do sine 330.
All right.
What's your answer?
Negative 1/√2.
No.
Negative half.
If it's half straight away, it's just negative half, right?
Yeah.
Yeah, be careful. It's only these ones that are weird. Cos 330. There, that's a weird one. 0.866. So, what's your answer?
√3/2.
√3/2, comma, tan 330.
Minus 1/√3.
Negative 1/√3. Beautiful. Anybody have any questions with that? No? All right,
No.
fantastic. Then we're moving on. Okay. Before I start this, let me just quickly check on our friends here. Queen is on. Novak's here. Good job. All right. Let's go. New page. Okay, before we start, we have to learn a few new identities. Now, these are for the advanced course, and then we'll do the extension 1 course formulas shortly. Okay. Well, actually, it's also pretty useful for you guys to get used to what will be given to you in your formula sheet. So this is a formula sheet that will be provided to you in all your exams for advanced to extension 2. It's good to start getting used to what formulas will be given and what won't be given. So let's have a look. They give you the quadratic formula. They give you those polynomial values. They give you the relationship of a circle. In trig, they give you sine SOHCAHTOA. They give you the area of a triangle. They give you the sine rule, cosine rule. And then they do give you these 4 trig identities that I'm literally about to write. Has anybody not learnt this? I guess I want to start do it that way. Has anybody not seen sec, cosec, cot before?
I haven't seen it.
Yep. Andy, anybody else?
I haven't
Yep.
seen it as well.
Yeah. That's it? Just 2? Okay. No problem. So let's do it. So, like I said, they're given these formulas, and then these are our extension 1 formulas that we're going to need. But, as always, if you have to refer back to a formula sheet, it probably means you haven't mastered the concept anyways. So we're going to learn a few new things. We know our sine, cos, and tan, but we have these new ones as well. So we've got sec theta, which is classified as 1 on cos theta. We have cosec theta, which becomes 1 on sine theta. And we have cot theta, which becomes 1 on tan theta. Now there is a trick to memorize this. The third letter here is the first letter here. Third letter, 1, 2, 3. 1, 2, 3. Okay. That just, you have to memorize that. Sec is 1 on cos, cosec is 1 on sine, cot theta is 1 on tan. There's a few more. Tan theta actually becomes sine theta on cos theta. So tan theta does become sine on cos. Now, if I had this tan replaced for sine on cos, 1 over sine over cos can actually be written as cos over sine. So cot theta can be cos over sine or 1 over tan. Now, sometimes we're going to use tan, and you'll know when. I promise you'll realize. I'll work you through that today. Sometimes you're going to use sine and coses. All right, and then a very important identity is sine squared theta plus cos squared theta equals 1. From that, if I just needed to make sine squared the subject, I would get sine squared equals 1 minus cos squared. And then, of course, if I needed to make cos squared the subject, I would say that is 1 minus sine squared. All right, I'm just going to stop there. Any questions to begin with? This is a bit of memorizing, so I'm sure you're writing it down, and we're going to use these formulas shortly, but these have to be memorized. All right, no questions there? Done. So let's have a look at these questions now. Take a snapshot of this, simplify. Let's do 4. I'll leave some for homework. Like I said, this is all being recorded anyways, you guys. So you can come back and re-watch it, pause it, all right, review it at your own time. All right, Emily, we're going to do the first one together. So, simplify cos theta times tan theta, right? Now,
Yeah.
do we have anything for cos theta? Well, no, cos theta doesn't become anything, right? There is no formula for cos theta. We've got a formula for sec, cosec, cot, tan, and cot again. And then sine squares and cos squares. So cos theta will just remain as cos theta, but what would tan theta become?
The sine, no, the
You're
sine
right.
over cos. Okay.
Sine theta on cos theta. That's it. So tan theta is sine theta on cos theta. And then what would you do when you see something like this and like
You
this?
would cross them out.
Why are you allowed to cross them out? Because they're all being multiplied. Keep that in mind. Equals sine theta. Great. Any questions there, Emily?
No.
No. Shania, let's do the next one together. Cot theta times sine theta. Again, Shania, you've got two choices with cot theta.
That would be cos over sine theta.
Yeah. And why didn't you pick 1 over 10?
So I can cross out the sine.
Yeah, love it. You see a sine theta there, so you're probably going to change the cot theta for cos theta on sine theta times sine theta. Cross out. Too easy. Good job. C, 1 minus sine squared. Queenie, what does 1 minus sine squared theta become?
Cos squared theta.
1 minus sine squared becomes cos squared. Anouk, D.
I'd first factor out the 2.
You are correct. You have to first factorize the 2 because that's the first thing. That's what you've been doing for the whole term, right? What have you learnt this whole term? Factorizing, expanding, solving. And that's literally what we're going to do moving forward with all of our topics, be it logs, exponentials, trig, doesn't really matter, but you still got to be doing factorizing, expanding, and solving. So absolutely right. We're going to factorize the 2 out. And then what's sine squared plus cos squared theta?
1.
Yes, it is. Sine squared theta plus cos squared theta equals to 1. Any questions from anyone? Nope. All right. Let's go to the next one. Proof this time. All right. Who do we have here? Oops. We need Novak, Andy. Expand. Okay. Prove. Prove the following. So prove A. Square root of 1 minus cos squared theta becomes sine theta. Now, whenever you're trying to prove something, you never work with both left-hand side and right-hand side and write it downwards. It's a poor technique. So the way you're meant to do it is you're meant to start with either side. So in this case, I'm going to start with LHS, left-hand side. So left-hand side becomes square root of 1 minus cos squared theta. Right? That's the left-hand side. And what we're going to try to do is prove the right-hand side. All right, Novak, you ready to do this one together?
Yes.
Yep. So square root 1 minus cos squared. What does 1 minus cos squared become?
Theta.
Sine squared theta. And then, of course, what are you going to do?
You cut it and it ends up being sine theta.
Cut it out, cancel it out. Becomes sine theta. And then what must you write in your last line? Equals?
Left-hand side equals right-hand side.
Yeah, you can just write. See, the way I'm writing it here, the way we read this is this. Left-hand side equals this, equals this, equals this, which equals right-hand side.
Oh, okay.
I don't actually need to go ahead and write LHS equals IHS. So as long as you write it like this, equal signs like that, the way we read it is LHS equals. So that's your working out. Good job. Any questions from anyone regarding what we've done there? No? No. Andy, next one, let's do it together. Left-hand side equals, all right, LHS. So left-hand side is this whole left bit here. Sec squared. What does sec squared theta become? 1 on?
Cos theta.
But it says squared this time. So what are you going to say?
Square.
Yeah. Yeah, that's it. So sec theta, hold on. Sec theta is 1 on cos, right?
Yeah.
If I put a squared there, what are you going to do with this one?
Put it in square.
So if I make this into sec cubed, you're going to say cos cubed. If I sec power of 4, you're going to say cos power of 4, and so on. Cos squared. So sec squared becomes 1 on cos squared times. What does 1 minus cos squared theta equal to?
Sine squared theta.
Beautiful. Simplify that. What's your next line? Just this times this.
Sine squared theta on cos squared theta.
Yep. And then look at what you wanted to prove. Do you feel like you've proven it? Sine over cos. So what's sine squared theta on cos squared theta?
Tan squared theta.
Squared theta. Which equals?
Right hand side.
Right hand side. You proved. Left hand side equals right hand side. Good job. Any questions?
No.
No? Alright. Emily, your turn. Let's go with C again. Left hand side. Okay. Tan theta. What are you going to use?
Tan theta. Yes. 1 second. Tan theta is sine over cos.
Sine over. You know how I memorized tan theta? If you wanted to use this, you know how we've got the acronym SOHCAHTOA? Tan is last, so it'll be sine over cos equals tan. I don't know if that helps, but I just do it like that. Sine over cos equals tan. Okay, delete. All right, back to this. Sine theta over cos theta. Yep. Times square root. And then what does 1 minus sine squared theta become?
Cos square theta.
Done. And then just before you move on, keep an eye on what the right-hand side is. Look at the right-hand side. Just sine theta, right?
Yeah.
Watch this. So what's going to happen with your cos squared and the square root?
It's gonna remove itself.
Yep. And then you're left with cos theta on the top and a cos theta on the bottom.
Yeah. Yeah.
And then what are you left with?
With your sine theta. It's right hand side.
Beautiful. Keep an eye on the right-hand side at all times. Like the answer is pretty much there, right? So like even with the other one, the one above. I mean, if you get stuck with, most students do get stuck with sine squared on cos squared. They forget that it becomes tan squared. But I mean, if you look at your right-hand side, it does say tan, and I'm sure once you were to see that, you'll realize, oh yeah, sine over cos is tan, and it's done. So keep an eye on it. It helps. All right, Anouk, we're going to do D together.
All right.
D. Left-hand side equals cot theta plus tan theta. And then we're trying to get it into cosec and sec. All right, Anouk, what do you want to do? Cot. Do you want to use 1 on tan or cos on sine?
Cos on sine?
Yeah. Any reason why you didn't pick 1 on tan?
Because tan is sine on cos.
Fair enough. Okay. I think the better response for you to look into is these two here, right? That we're trying to prove.
Yeah.
Are they in terms of tan?
Pardon?
Are they in terms of tan? Will these two be written in terms
no.
of tan? No. What does cosec become?
1 on sine theta.
Yeah. And what's sec going to become?
1 on cos theta.
So these guys are in terms of what?
Sine and cos.
That's why I know I've got to change these two in terms of.
Sine and cos.
Yeah, that's it. That's the logic. It's cool.
Alright.
So if I had another question another day and then this was in terms of tan, well, would I go and change these two into sines and causes or leave them as tans?
I didn't hear that.
Okay, if I had this question, another question, right? But if I had
Yeah.
this being in terms of tan, would
Yeah.
I go and change these two in terms of sines and causes?
No.
No, you would probably leave them as 1 on tan and then this one as tan.
Yeah.
Yeah, just so everybody gets it, I guess gets clear with that, when to use 1 on sine compared to, when to use sine on cos compared to tan. All right, let's keep going, Anouk. So we're trying to get to 1 on sine, 1 on cos. Just keep that in mind. Let's go. Cot theta, what does it become?
Cos theta on sine theta.
Plus sine, sorry, yeah, I just said it. Doesn't matter. Sine theta on cos theta. Okay, next line. What does your heart tell you to do when you see a fraction plus another fraction?
You can do the what's missing method.
Say it again. Oh, yes.
You know that?
Missing.
Yeah.
That's it. That's the idea. So common denominators and then what's missing.
Yeah.
Bang. So what's your common denominator?
Sine theta times cos theta.
What's missing from sine and sine cos?
Sine cos squared theta.
Oh, yeah, so the top becomes cos squared theta plus, and then again you can
Squared
multiply
theta.
this. I'll stop there for a second. Does anybody have a question with how I've done that? No, we all understand how I made that into a common denominator. Okay. Cos squared plus sine squared, what does it become?
1.
And then, isn't this technically what we wanted? 1 on sine, which becomes, and then 1 on cos, which becomes? You happy
Yeah.
with that?
Yeah.
Anybody have any questions with what I've done here now? No? Okay. Let's do one more. I'm going to do F. I'll leave E for you guys, we'll do F. Who wants to give F a shot with me? F, sine on 1 plus cos. F. Sine theta on 1 plus cos, that's equal to 1 minus cos on sine. Anybody going to put their hand up? Or am I going to pick someone? Alright, let's go. Shania, you're the lucky one.
Thank you.
So, before we start this, let's go back up and have a look at our strategy that we've been doing. So usually it's been left-hand side, and then we get it to our right-hand side, correct?
Yep.
The reason why we've chosen this strategy is because obviously, can you do something to 1 minus cos squared? Yes.
Yes.
That's sine squared. Can you do something to tan theta? Yes, that becomes sine on cos. And can you do something to cot theta? Yes, tan theta, yes. So on, right? Now,
Yeah.
we're up to this question. Can I do something with just sine theta?
No.
1 plus cos.
Nope.
1 minus cos and sine. So pretty much what I'm trying to make you guys realize is we're not going to be able to prove the left-hand side is going to become the right-hand side. Right? There's no way you're going to change this to make it become this. So, Shania, if that's not going to be possible, what's another option we can do here? Again, just think about everything you've done this whole term, and just tell me what you would do when you see a fraction equal to a fraction.
I'm not sure. I think. Do you cross multiply? I don't know.
Yes. You will cross multiply, right? And then you might get to a result that, that is true, and then we'll see what we're going to do from there. So let's cross multiply. So let's use the actual question. So you're going to get sine times sine, which becomes sine squared. Then you'll get 1 minus cos times 1 plus cos. Yep.
Yeah.
Does this look familiar to you? 1 minus cos and then 1 plus cos?
Yep, the difference of two squares, so that's, yep.
Beautiful. And does this look familiar now?
Yeah.
Yeah. So can you see how that is actually something we know is true?
Mm-hmm.
But you aren't allowed to stop there. So you're not allowed to just go, okay, yeah, sweet, I proved something that is true, therefore this left-hand side does equal to the right-hand side. No, so that's part of your working out. Right, working out. The actual answer will look like this. So your first line is this. So now you know the actual first line. So what are you going to write? That's going to be your first line. So you're going to write sine squared theta equals
1 minus cos squared theta.
cos squared theta. Then you're going to factorize 1 minus cos squared, which would become what?
Okay.
So can you see how I'm just trying to rewrite it backwards?
Yeah.
And then what's sine squared theta equal to? Sine theta times sine theta.
Sine theta.
Yep. And then how am I going to be able to prove this guy? Well, can you see if I divide 1 plus cos here and divide the sine theta here, I pretty much prove this result. So let's see if that's true. This is, I'm left with sine theta on 1 plus cos. On the right hand side, I'm left with 1 minus cos divided by this sine theta.
Right.
Yeah. And see, now you proved it.
You basically just go backwards until you rewrite the question? Or?
That's the whole point, yeah.
Okay.
You're not, let's reiterate. You're not allowed to start with the question, get to a result that is true, and say, therefore, this works. Well, yeah, that doesn't mean you proved this. That just means something else is true. But what you do now, you know that becomes your first line, that becomes your second line, and essentially this will become your third line. So when I'm looking at your answer, this is what I see. I see that you started off with that, then you realize that sine squared is actually sine times sine, and that becomes a difference of two squares. Then you decided to divide this, and prove the result.
Okay.
Yeah. Anybody have any questions with that?
Yeah, I got a question, Sam.
Yeah, tell me.
You said earlier that when you're doing proofs, you can't work with both sides.
Exactly. So that's like you know the English language, how you learn I before E except after C. It's not always the case, is it?
No.
Even with that rule, it's not always the case. There are certain words that unfortunately doesn't apply to. So it's just that one case that I just had to show you, and that's why I said let's do F. So and how would you realize, like, how would you have realized, yeah, it's not going to be that kind of question? Well, like I said, you would look at this and you go, well, I can't actually change this for anything. There is no rule for sine theta, or there's no formula for just cos theta. And that's how you would realize you're meant to do that, and then, yeah, left hand side and equals to right hand side.
Yeah, right.
It's an exception.
Okay.
Unfortunately, right? There's always going to be an exception. Yeah. It's like rationalizing the denominator, right? That's all you've learned, right?
Yeah.
You just learned rationalizing the denominator. But the truth is what? You can also
rationalize the numerator too.
The numerator. You guys just have never done that. But you can. Root 3 times root 3 becomes 3 on 3 root 3. And then it becomes back to 1 on root 3. So you can rationalize numerator. In fact, in the HSC, rationalizing numerator is a common technique because they know that most of the state knows rationalizing the denominator. But a lot of the state don't know rationalizing the numerator. It's just, there's an exception, unfortunately. But, you know, that's what happens with exposure. The more you expose yourself with exam questions, the more you get comfortable with these style of questions, which we will do. In fact, right now, since you raised it, why not? Let's do 2 or 3 exam style questions. So let's go to here. Let's go year 11 exams. Let's go Sydney boys. That's a bit open. Firstly. Nope, no trig there. Trig. There we go. Hey, look at that question. Doesn't that look familiar? Let's just do it. But please, you know how many times I've emphasized with you guys to do exam questions. This is what I mean. It's so simple. You complete a concept. There we go. We just learned, I guess, how to prove. You just go jump straight onto exam questions and actually attempt them. Let's try this question. Cos theta, sec theta, minus sine squared. So, Anil, since you started this, let's just quickly do it together. Can you see how this will be a left-hand side equals right-hand side question?
Yeah.
And the reason why you would know that is because you can change sec theta for something. You can change, sine squared for something. But with the other one, you just couldn't. All right. So left-hand side, whoops, up here. Left-hand side equals this. All right. Cos theta, you would leave it. What does sec theta become?
1 on cos theta.
What are you going to do now?
Cancel out the causes.
Equals?
And that equals with the right-hand side.
Simple, right? How many marks?
Yeah.
2 marks. So you guys learned it in 30 minutes and you're already able to answer a prelim exam for 2 marks. Here's another 2 marks. Look, right there. Tan 150. So let's do that one since we're here, and then I've got to move on. Tan 150 times cos 60 on sine 30. All right, plug it into your calculator. Tan 150 equals. Anybody can tell me the answer to what tan 150 becomes?
1 over root 3.
That's not correct. Close.
Minus 1 over root 3.
Yes.
Yeah.
All right. Times cos 60.
1/2.
Sine 30.
1/2.
Now, usually when we see fractions, upon fractions, it's probably best not to deal with them like this unless you're really good with it. My next line, I think, would be negative 1 on 2 root 3, right? 2 times root 3 is 2 root 3. And then just write divide. Divide 1 over 2. That just means times by 2 over. And then obviously what would you do with your 2? Your 2 and 2 cancels out. Your final answer is negative 1 on root 3. Easy. Any questions there, you guys? It's another 2 marks. No questions? We're all good? All right, done. Let's do equations. Okay, before we start equations, We've got to go through a bit of theory. What's the first thing we need to learn? We need to learn radians and degrees. Radians and degrees. Okay. So radians. All right. So let's go from radians to degrees first. So radians to degrees, converting. So what we're going to have is in radian form, we're going to usually have something that says like pi. So it's always going to have a pi. So radian is going to be pi over, let's just say 3, right? Our pi value now stands for 180 degrees. So pi is equal to 180 degrees. So this would be called radian form, pi on 3. In degree form, pi is equal to 180. So all you've got to do is just do 180 divided by 3. Can everybody confirm they understood what I said there?
Yes.
Yep.
Yeah.
Yeah.
Great. Then that's it. Let's do a few more just to make sure. So we've got 2 pi on 5. Let's plug that into our calculator. Remember, pi just stands for 180 degrees. So you just go 2 times 180 all over 5. Should get you
72.
72 degrees. So that's easy. Radians to degrees is pretty straightforward. Now what we've got to do is go backwards. So we're going to go degrees to radians, which is the more important one for us in our course now. So we might have a question that says 45 degrees, and we're going to convert it to radians. The trick to it is you just do 45 divided by 180 on your calculator. Whatever fraction that becomes, which is a quarter, you'll just put a pi on the top. So you're not meant to put pi in your calculator. Right, so one more time. All you do, you 45, divide 180, look at the answer, it becomes 1 on 4, put a pi on top, becomes pi on 4. Okay, let's do another one. 120 degrees, 120, divide 180. I see 2 over 3. So what's the answer I'm looking for?
Two pi over 3.
Emily, Shania, Queenie, you all understand this?
Yep.
Yep.
Okay, last one. 330 degrees. Change that to radians. 330 divided by 180. Get an answer. The answer is 11 pi over 6. And we're done. Andy, that makes sense to you as well, buddy?
Yeah.
Yeah, great. All right, so that's straightforward. What we're going to do, we're only going to use radians right at the end. We're going to have everything in terms of degrees. Our last line, we're just going to convert to radians. And that's part of the new syllabus, whereas the old syllabus, that was only required in Year 12. Now it's in Year 11 and Year 12. So not too difficult. We'll just we'll look at that once we need to when we're solving. The next thing is all stations to central. All of our trig identities are positive here. Sine is only positive here. Tan is positive here. Cos is positive here. That means if I said, if I gave you an example, I gave you cos theta equals to a half, that's positive because it's a half, right? It's not a negative number. That means cos would be positive here and here. If I gave you cos equals negative a half, now that becomes here and here. Because cos would be negative in the other two quadrants. Does anybody want me to explain that again? No. No, it looks like you guys are doing really well. You're just shy. So let's go with sine theta one more time. Sine theta equals negative 1 on root 3. Novak, if sine is negative, where would that be?
If sine is negative,
Yep,
it would
see,
be
sine is
positive in sine, negative in tan, and negative in cos.
correct. So right here and right here. Okay. Good. Everybody get that?
Yeah.
All right, done. So the angles we need to know are these. If it's here, the angle you'll find is theta. If it's here, the angle we need is 180 minus theta. If it's in this quadrant, the angle we need is 180 plus theta. And if it's in the cos quadrant, the angle we need is 360 minus theta. And then since we're here, I'll make an extra note. Just the way I do my math, I will never inverse a negative. So I'll straight away know if you're going to be doing it my way or your teacher's way with these questions, because your teachers will inverse these negative numbers. Our technique, we don't inverse negative numbers. All right. Any questions before I start looking at these questions? All right, let's do it. So, one more time, that line we'll need at the end. This we'll need during our working out, and then never inverse a negative. Okay. Queenie, we're going to do the first one together. So A, solve sine x equals root 3 on 2. You ready, Queenie?
Yeah.
All right. What's your first step?
X equals.
Yeah. X equals. You got to get rid of the sign. X equals.
Fine.
Plug that into your calculator. What do you see?
60.
60 degrees. Let's stop there. Anybody have any questions for us here?
Do you have to put that into radians?
No. So your teachers might. What we're going to do is we're going to keep everything very uniform. We're going to keep everything as degrees until our very last answer. We're just going to convert to radians.
Okay.
It's easier. Okay, so 60 degrees, and then we need another solution, right? We've got to work out our all stations to central every time. Where is sine positive, Queenie? Sine positive. Where is sine positive in these 4 quadrants? Queenie, you there? I asked you. You're on mute, Queenie.
Oh,
There you
sorry.
go. It's fine. All right. So, yeah, where is sine positive?
In A and S, and then negative in T and C.
Yeah. Well, you don't need the negatives. You'll only need the negatives if it was a negative, like in this question here for C. It says cos is negative, then we will take that into account. But right now, we just want to know where sine is going to be a positive number, which is A and S. This was theta, so this was the first angle you get, which would be, in this case, X, for example. This is 180 minus theta, so what's your other answer you're meant to get? 180 minus 60 becomes what?
120.
120. And those are your two answers, and then we convert to radians. So I'll stop there. Shania, Emily, did every line make sense here?
Yeah.
Emily, same thing? All good?
Yeah, it did.
All right. Beautiful.
Sam, do you have to convert?
Do you have to convert? Yes, you must now.
Okay.
New syllabus. Before you didn't have to, now you do.
Okay.
Okay, let's do B. So once you get your first answer, all stations to central, get your next answer. Just keep that in mind. B. Tan x equals 1 on root 3. Andy, this is your one. Tan x equals 1 on root 3. All right, first line, what are you going to do, Andy?
Inverse tan.
That's it. What's your answer when you inverse tan 1 on root 3?
30.
30. And then what do I draw?
All stations to central.
And then where is tan positive?
T and A.
This is your first answer. You already have it. There it is, theta. Your first answer. And this one's 180 plus. So what's the next answer?
210.
210. And then convert for me.
Six, 10, pi over 6. Yeah.
Correct. And then this one will become 7 pi over 6. Done that. Anybody have any questions there? Okay. And look, we're going to do C together.
All right.
What's the first thing you realize?
You don't inverse a negative.
Yes, good man. Don't touch this negative. All right. The only thing that this negative tells you is that when we're going to draw out all stations to central, where is cos negative?
In the fourth and
No, cos negative in the second and third.
in the third and yeah.
Yeah, careful. All right, let's do this. So, the way I will do this is we're going to draw x with a little bit of a hat on it. The reason why we do that is because that's not going to be our actual x value. So x hat equals cos inverse root 3 on 2, which becomes, so ignore the negative.
Yeah. It becomes 30.
30. Now the reason why we do this x hat is because that's not the actual answer. See, x or whatever theta would be in this quadrant here, which isn't it isn't part of our solutions. We're meant to have s and t, but to do s, I need theta, and to do t, I also need theta. But now I know what theta is. It's 30 degrees. So what's the actual x values that we're looking for, Anouk?
150 and 210.
Yes. Now, a lot of students say, oh, Sam, what would have happened if I inversed the negative? Well, you guys can go ahead and do that. And you're going to see you will get 150, but then good luck trying to get the 210. Okay, convert.
5 pi on root 6 and 7 pi on root 6. I mean, not root 6.
Yeah, I was going to say, why are you saying root? Just 6. All right, 7 pi on 6. Again, Shania, Emily, Queenie, Andy, this all makes sense. Novak.
Yeah, it makes sense.
Yeah.
Makes sense.
All right, just biggest thing you want to remember. Look, again, I got to confirm. Your teachers will inverse this negative, and then they will show you how to change these quadrants. I will not change that because that gets confusing. We're going to keep everything uniform. So my angles will never change. They will always be this. All you've got to remember with my technique is this cannot be part of your solution. That's just there to get you your theta. And then this becomes our solution. So no inversing negatives. And then once you worked out what your small angle is, I guess, subtract, add accordingly. Okay, let's do D. 2 sine x plus 1. Novak, this one's yours. 2 sine x plus 1 equals 0. We've got to solve for x. What's the first thing you will do?
So bring it to the other side. So
Yes.
sine x would be minus 1/2.
Minus 1 divided by 2. Good job. And then you're obviously going to inverse.
Sine but without the negative. So it would be 30.
Inverse sine of 0.5 does become 30. Yep, then what do I draw?
The all stations to central.
You guys got to get used to that. Once you finish this off, you stop. All stations to central. Then you ask yourself, where is sine?
Negative. In cos and tan.
You would circle them. And then what's the actual answer we're looking for?
180 plus theta, and that's 210 and 330.
And then final answer.
Change it into radians.
That's it. Okay. And last one, E. E cos squared x equals a quarter. Okay. Who wants to try this one with me? All right. Andy, let's go. Cos squared x equals a quarter.
Yeah.
What's your first thing you're going to do?
You bring the d square root it.
Correct. So what's your next line? What are you going to write?
Cos x equals a half.
Incorrect. Come on. Someone help him out.
Like,
Does it equal
plus
1/16?
Yes. Someone just said it. Plus minus. What were you saying, Emily?
I just messed it up in my head.
Okay.
Nothing.
1 on roots. Yeah. Plus minus. Right, Andy?
Yeah.
Yeah, you can't forget that. Okay, so we're going to have, technically, you're going to have this. So cos x equals to a half, and cos x equals to negative a half. But let's see if you guys agree with something. If you know that cos is going to be positive and cos is going to be negative, what does that mean with your all stations to central?
You do
Andy?
all of them.
Yeah, you're going to do all of them, right? So what you can just memorize, I mean, if you're going to do, if it's always squared, you're just going to get your first answer, which would be theta. So x equals, what's inverse cos of a half?
60.
60 degrees. And then technically, the next answer for this and your other two answers for this are just going to be all the other three. So 180 minus, 180 plus, and then 360 minus. Does that make sense, Andy?
Yeah.
Right. And then, of course, convert, which I'll just leave to you guys now. I think you guys all get the converting bit. Emily, that makes sense, what I've done there with the squared and plus minus, and then the fact that I chose all four.
Yeah, because it's since it's all even, it would be in all of them.
Yeah.
I get it.
Yeah, correct. Correct. Too good. All right, done. Let's go and do some different angled ones now. We'll choose a double angle and then half angle, and then that's it. We're going to move on to the extension 1 stuff. All right. Bang. So B, cos 2x equals negative a half. All right, Shania, let's do this one together. Cos 2x equals negative half. All right, next line is definitely just going to be 2x. And you're only going to inverse what?
Half.
Do you agree with me writing 2x there?
Yep.
Okay. What is inverse cos of a half?
60.
60 degrees, okay. Now, what are we going to draw?
All stations to central.
And then?
Where is cos negative?
Beautiful. That's the question you ask yourself. Where is cos negative? And you would say, there and there. So my next line, instead of writing 2x with my hat, I'm actually just going to write 2x.
Okay.
Equals 180 minus 60.
120 and
then 180 plus. Okay. Any questions from anyone so far? So I ignored the 2x, right? But what is the 2x doing? Well, the 2x is actually allowing you to move 2 revolutions. So if I had an angle here, if I add another 360, I'm still going to be here, right? If I had an angle that was here, if I add 360 to that, I'm still going to end up here as well. So what 2x is doing is it's allowing you to go for 2 revolutions. So what we must do to counter that is we must add 360 degrees to both of these solutions. So the next 2 solutions we're going to get is 120 plus 360, which is what?
480.
480, and 600.
Yep, 600.
And the reason why we can do that is because once I divide by 2, what's going to happen? You're going to get one answer here that's 60. You're going to get another answer that's 120. But look, these answers are also less than 360 degrees. So they're still in my domain. I didn't talk about the domain actually. Sorry, let me go back. Our domains are always going to be from 0 to 360. So you want all the answers from 0 to 360 degrees. And there it is. If I didn't add the 2 revolutions, I would have missed these last 2 answers. Does that make sense, Shania?
Yep.
Another way to look at it, look, this was just 1x, right? Up here, 1x.
Yeah.
This was 1x. 1x, 1x. All right. So usually with 1x, we've got 2 answers. 1, 2. Now if it's 2x, you're going to get 2 sets of 2 solutions. So that's 1 set, and that's your second set. So 2 times the answers. So instead of 2 solutions, we've got 4 solutions.
Okay.
If it was 3x, you're going to have 6 sets of solutions. 3 sets of solutions. 3 sets of solutions. Does that make sense?
Yep.
All right. But anyways, all you guys got to remember just adding 360 to both of those, both that and that. All right, let's do C. 3. Well, I'll change the 2x to 3x, just so that way we can see what happens with the 3x for a different question. 3 tan 3x minus root 3. All right. Emily, let's do this one together. What do you reckon?
Wouldn't you want to move it to like the other side
Yes.
I don't know.
So that becomes tan 3x equals positive root 3 divided by,
3.
yeah, because you're going to plus this guy and then you're going to eventually divide this one out, yeah?
Yeah.
Okay, then inverse tan,
Uh,
what do you get?
10
Inverse tan,
over
this
3. 30 degrees.
30. Then we stop, we draw all stations to central. Is this positive or negative for tan?
Positive 10, so it would be an A and T.
That's it. And then 180 plus 210. So usually, let me just make it clear. If I didn't have a 3 here, you're done. Do you agree with that?
Yeah.
But now, because
Yeah.
I've got a 3, I'm going to add 360 degrees a few times until I get my 3 revolutions, or 3 sets of solutions. So, here we go. Emily, you're going to add 360 to these two firstly.
So it'll be 390
Yep. And
and 570.
570. There you go. Now you've got 2 sets. 1, 2. We need another 2. So we're going to add 360 to these two numbers now.
So then it'll be 750.
Yep.
Then it'll be 930.
That's it. And look, 3 sets of solutions. 1, 2, 3. And then what are you obviously going to do now? I don't like this 3 here.
Divided by 3.
Done. 10. 210 divided by 3 should give you 70. 390 divided by 3, 130. 570 divided by 3, 190. 750, 250. 930 divided by 3 should be 310. And then what's the last line that we must do, which is annoying? Convert this to radians. So this guy becomes like 31 pi on 18, 250 on 180, 25 pi on 18, 190. All right. While I do that, you guys, anyone have any questions for us?
Sam,
Yeah.
what if the domain is different?
What if the domain is different? Good question. So again, your teachers will show you how to change the domain. Okay. So let's confirm something. One sec. I'm just finishing this off. All right. Beautiful. Oh, 18. 18. Okay. Good question. What if the domain was different? Have we all copied this down?
Yeah.
I'll just wait. Okay. Anyone still writing? All right. So if the domain, okay, let's confirm how your teachers will do it, real quick. So your teachers will tell you if this is 2x, to actually change the domain. So they'll make you guys do this to 720. Okay? We didn't do it like that. So what we do is we add 360. We're keeping everything the same. We're not changing the domain. Now, if the domain was different, so let's just say the domain was from 0 to 180 in the original question, Andy, if the question said do C from 0 to 180, what would you do now? Look at your answer for X. What doesn't work out?
Everything above 180.
Yeah, so this won't be there, this won't be there, this won't be there. So you'll just cross them out, and the only 3 answers you're going to have is the first one, second one, and third one.
Yeah.
Simple.
What if it's a negative domain?
So what are you going to do? Instead of adding 360, what would you do?
Minus 360.
Minus 360.
Okay.
Are you allowed to subtract 360? Yes. because it's still within the same location, right? If I was here to start with, if I add 360 or subtract 360, they're still going to end up getting the same answer. They're still always going to be here. Okay, any other questions? Your teachers will do this very differently, you guys, so just be careful when you do start this at school. I would recommend going back over this video and just re-watching everything so you understand what we've done. Okay, let's move forward to extension 1 now. Okay. More formulas to memorize now. Extension 1. Trig. Okay. When you're looking at the booklets, when you're going over it at your own time, when I've written further trig here, that would be extension 1. These ones are called basic trig. Basic. These are advanced. So basic is advanced, further trig is going to be extension 1 word. Okay. We're going to need to find cos, let's say 75 in exact value form. So the problem is if I do cos 75 in my calculator, it's going to get me 0.258, and if I use that trick that I showed you guys, like squaring it, it just won't work because it will give you 0.0669, which still isn't a fraction, and then you can't really convert cos 75 to an exact value using that trick that we did before. So that only works for your advanced questions. For your extension 1 questions, we've got to learn a way to actually expand cos 75. And that's where these 3 new formulas come in. So we've got cos A plus B. If I had cos of an angle plus another angle, to expand that becomes cos A, cos B, so cos A, cos B, and then minus, so opposite of plus, minus, sine A, sine B. If I had sine A plus B, this becomes sine A cos B plus, so this one stays the same, if it's positive, it's positive, cos of the first, sine of the second. So sine the first, cos the second, then cos the first, sine the second. This one here, it was cos the first, cos the second, minus sine the first, sine the second. Okay, then we've got tan A plus B. Tan A plus B is tan A plus tan B on 1 minus tan A, tan B. Again, these are given to you in your formula sheets, but you'll have to memorize it, I promise you. If it was a negative, this becomes a positive. If this was a negative, this is a negative. If this was a negative, this is obviously a negative, and that becomes a positive. How will you memorize this? Some of my students have just written them down and placed them in front of their on their wall, in front of their in their study room or whatever, their study desk. Some of them have done that. So some of them take photos of this and put it as their screensaver on their phone, or just old school, write it, 10 times, you'll memorize it. I promise you. It's not that bad. So cos first, cos second, and then minus sine first, sine second. This one, you sine the first, cos the second, then cos the first, sine the second. Oh, that's a mistake. That should be sine B. Right, cos A sine B. And then this one's tan A plus tan B, 1 minus tan A, tan B. All right. Okay, let's see how this actually works. So cos 75. Anouk, I think you and I have done this one before.
Yeah,
You
we
remember
have,
this from last year? Yes.
Yeah.
So cos 75 is going to become cos. What's your two angles you're going to pick?
30 and 45.
Yes. And the reason why you pick those is because we know how to find exact values from advanced of cos 30 and 45 and 60 and 90 degrees, for example, right?
Yeah.
So you didn't pick 50 and 25. I mean, cos 50 plus 25 still gets you 75. But we don't know the exact value of cos 50 or 25. So that's not going to be very nice. So we're going to pick your degrees you would usually pick. Let's just write in here. Will be 30, 45, 60, 90, 120, and then pretty much increments of 30 here onwards. 150, 180, so on. Okay. Cos 75 is cos 45 plus 30. And then, what's your next line?
You expand it.
So how do we expand cos 45 plus 30? You have to use this formula.
So it'll be cos 45, cos 30 minus sine 45, sine 30.
Okay. Anyone completely lost? No? You sure? Okay. Let's move on then. Next line. What does cos 45 become?
1 over root 2.
Cos 30?
Root 3 over 4. 2 I mean.
Sine 45 becomes the same as cos 45.
Yeah.
And then sine 30.
1 over root 2.
No,
1 over 2.
1 over 2. Be careful.
Yeah.
Okay. Next line. Root 3 on 2 root 2 minus 1 on 2 root 2.
Yeah.
And then?
Or you just do the what's missing method.
Yeah, but they're the same denominator, aren't they?
Yeah. Oh, yeah, that's right.
And
Then you rationalize it.
Then you rationalize. 2 times 2, 4. And that's why we can't do the squared technique, because you can't do it for a binomial like this. Okay. Shania, did we do this one last year as well?
I don't remember this. I don't think we did.
All right. Queenie, you've done it, right?
I did a bit of it.
Okay. Novak, what about you?
Yeah, I remember this.
Emily, this is, and Andy, this would be foreign to you guys?
Yeah.
Yeah, I've never done this before.
Yeah, I understand. All good. But did it make sense, Emily and Andy, what we've done?
Yeah, it makes sense.
Yeah. It's new formulas, I mean, but you'll get your head around it, I promise you. Everybody does. So let's do another one. We'll use the same angle. Can I go down? Have we all copied it already? Okay.
Yeah.
Let's go to sine 75. Oh, I won't do the same angle actually because that'll be silly. Let's do sine, okay, let's do sine 15. Andy, you want to try this one with me? 15 degrees. All right, we want to find this in exact value. Find exact value of sine 15 degrees. All right, go. So sine. What are your two angles that you're going to pick? From here to get you 15 degrees.
45 and 30.
Yes, and what else could you have done? Just so you know that it would also work.
60
Anybody?
and 45.
Yeah, 60 and 45. I mean, that's not a problem as well. They'll still work out, okay? Don't think that just because we're about to do 45 minus 30, you feel like that's the only way you can get 15. You can also have done it via 60 minus 45. You just want to pick these angles because we actually can get them into exact values. You don't want to really pick any other ones. All right, good job, Andy. Now, next line. Sine becomes sine of the first, cos of the second. So, tell me, sine what?
45.
Yep. And then?
Cos 30.
Yep. And then for sine, if it's negative, it remains a negative.
Cos 45.
First. Correct. And then sine the second. Okay, sine 45. What does it become, Andy?
A half. 8.
Not exactly a half.
One over root 2.
1 over root 2, that's better. And then cos 30.
Root 3 on 2.
Yep. Cos 45.
One on root 2.
1 on root 2. And then sine 30.
1 on 2. Half.
Yeah, just half. Okay. Next answer. Root 3 minus 1 on 2 root 2. Same answer as before. Root 6 minus root 2 on 4. Any questions?
No.
Okay. Let's do 10. 10, what was it? 15. Okay. All right, Emily, you want to try 10, 15?
Okay.
It's going to be a little bit harder because, of course, 10 itself has fractions, right? The formula has fractions, so it's going to be a little bit more annoying, but let's do it. 10, 15 equals 10 what? What are you going to pick?
You can do 45 minus 30 or 60 minus 45.
That's it. We'll just choose this. The expansion is, do you feel like you know it?
Is it 10 45
Yes. And then?
plus 10 minus
Yep.
10 30?
Yep. The bottom one becomes 1, and then that changes to a plus.
Yeah. Then it comes 10 45 plus 10 30.
Not plus, just times. 1045 times 10. So 1045 30.
Um,
Okay.
Now,
Now, calculator time. 10:45. What is it?
10:45. It's 1.
That's it.
1.
10:30.
1 over square root 3 over 1 plus times 1030 squared equals 1 over, yeah.
Perfect. Okay. Now, everybody gets stuck from this to the next line. It's because they haven't trained themselves yet to, if you've got a fraction over a fraction, then it's probably better for now to split this up. So what I'm going to do is in my next line, we're just going to work on the numerator, which will become this, root 3 minus 1 on root 3. Do you agree with that? Times this one by root 3 over a common denominator of root 3. So that is just the numerator. Can you see that or not? Is that too fast?
Yeah, I got it.
Okay. Emily, what about you?
Yeah, I got it.
Okay. Then we use division. Root 3 plus 1 on root 3. Right? Root 3 plus 1 on root 3. And in that way, it's super easy to work with because now those two will cancel out. So it's a lot easier to work sideways for fractions and fractions than it is to work down. Any questions there, Emily?
No.
And then what must you do to here to rationalize? You're going to times top and bottom by what?
Root 3 plus 1.
Minus opposite. It's going to be the opposite of the bottom. If it's a plus, it's a minus. If it's a minus, it becomes a plus. The bottom becomes 3 minus 1, which is 2. Will become root 3 and 3, which is 3. That becomes plus 1 minus 2 root 3. Final answer is 4 minus 2 root 3 on 2. Ugh. And we're done. Finally. Whole lot of stuff there. Alright, anyone want me to go up? No. So let's go through that one more time. I think 1045 became 1, 1030, 1 on root 3, and then same thing with the bottom, 1 plus 1 on root 3. Then I found this as a common denominator, so I'll just times this one by root 3 on root 3, which becomes this, root 3 minus 1 on square root of 3, divide, which is my fraction sign, and then the denominator. Multiply and flip the second, cancel out. I'm left with here, multiplied by the conjugate, so minus. This becomes a perfect square, so that's what I've done to expand. If you're wondering what I've done there. And then all divided by 2, so it becomes 2 minus root 3. If you want to check if your answer is right, I mean, before you go out of your exam, you'll just plug in 1015 in your calculator, and that gives you 0.267, and then put this into your calculator, 2 minus root 3, also gives you 0.267. They're the same answer, you know you're right. I'll let you guys do sine 105 now at your own pace. So write this down, I'll give you a few minutes to work it out yourself. Sine 105 degrees. If you don't know what your first line is, let me know and I'll start you off. All right, sine 105. Let's do this. So that becomes sine. What did we pick? I'm thinking of 60 plus 45. Anybody actually have the answer for sine 105 already?
Yeah, I got it.
What'd you
So,
get?
I think
Root 3 plus 1 on 2 root 2.
Root 3 plus 1 on 2 root 2.
Yeah.
So that you haven't rationalized. So that becomes root 6 plus
Right.
root 2
over 4.
on 4.
Yeah.
Anybody not get that? So do I need to do it or? Girls, you're all good with this? You got this as well?
Yep. Got it.
Okay. You'll have work solutions anyways once you get this booklet. Let's do question 2. Very cute, and it says cos A is 3 over 5 and tan B is 2 root 6 over 5. Then simplify sine A plus B. Okay. Sine A plus B. Well, sine A plus B becomes sine A cos B plus cos A sine B. Now, I mean, you were given cos A, there it is, but you weren't given sine A or cos B or sine B. Does anybody have any idea of how I'm going to use these two results to try to get these other values? Okay. Think of your right-angled triangles. What do you know about cos A? This is going to be what over what? Still nothing? Okay. Yep, someone? No? All right, I'll keep going. If I draw a right-angled triangle for this one here, and I've got the angle being A, I know that this must be adjacent, which is 3, and I know hypotenuse must be 5, which means simply, in this case, this number here is going to be 4. Or you could have used Pythagoras to actually prove that, but this is a simple 3, 4, 5 triangle. From that, I'm definitely able to get sine A. Sine A becomes opposite over hypotenuse. Does that make sense, everybody?
Yep.
Let's do it for tan B. There's B. I need cos and sine, so tan is opposite over adjacent. Can someone work out the value for my hypotenuse, please?
Is it 7?
7 is correct. So a squared plus b squared, square root of that gets you 7. And then of course, can you work out what sine b and cos b is from there? Absolutely. Sine b is opposite over hypotenuse. And then cos b equals 5/7. Now that you have everything, we can actually do the question, which is fairly straightforward. Sine A is 4/5 times cos B, which is 5/7, plus cos A is 3/5 times sine B, 2√6/7. Final answer, 4 times 5 is 20, 20 on 35 plus 6√6/35. And of course, you could have made them a common denominator. And that's it. You can't actually simplify it any further. Any questions there? Okay. Shania, let's do B together. Cos A minus B. So expanded would become like that, right?
Yep.
What's cos A equal to?
3/5
Times?
5/7
Plus?
4/5
Times?
2√6/7.
Easy. 15 plus 8. Root 6 on 35. Okay. Now we've got a few more formulas to memorize. So trig in year 11 is the topic that would have the most formulas out of everything in year 11 and year 12. So there's a lot, just so you're aware. It's a lot of memorizing. You can't neglect this one. C. It does say to find sine 2a. I'm not going to prove it or use the hint. I'm just going to tell you what the answer is, and I want you guys to memorize them. So, actually, let's go up. Let me just see if I can put it into that one section where we wrote. Oh, no, I can't fit it in there. Oh, I can fit it up here. That'll work well. Okay. Okay. Now we've also got double angle results. So what usually happens if I let B become A, you would get A plus A, which becomes 2A. And same thing with sine. That's A plus A becomes sine 2A and tan 2A. So we call these our double angle results. Now I like using theta for these. So sine 2 theta, which means theta plus theta. So sine 2, not sine squared, sine 2 theta becomes 2 sine theta cos theta. 2 sine theta cos theta. Cos 2 theta becomes cos squared theta minus sine squared theta And now this isn't in your formula sheet, so you have to memorize this. Tan 2 theta becomes 2 tan theta on 1 minus tan squared. So sine 2 theta is 2 sine theta cos theta. Cos 2 theta is cos squared minus sine squared. Tan 2 theta is 2 tan theta on 1 minus tan squared theta. Okay, have we all written that down now?
Yep.
All right, those double angle results is what we're going to need to work out this answer here, sine 2a. So sine 2a becomes 2 sine a cos a. Simple, right? Sine a is 4 over 5, cos a is 3 over 5. 2 times 4 over 5 times 3 over 5. 12, 24 over 25. So if you know your formulas, the questions are really easy. That's how trig works. If you don't know the formulas, every question is going to look really, really hard. D, tan 2a. Tan 2a becomes 2 tan a on 1 minus tan squared a. 2 times tan a. Tan a was, I don't have it. Tan a equals opposite over adjacent, 4 over 3. So 2 times negative 24 on 7. Any questions, you guys? Let's do it. Let's do these ones next week. Perfect, beautiful, beautiful. Prove. Let's do maybe these 3. Okay. Left hand side for A. Queenie, let's do A together. Sine 2x times cot x. Queenie, you ready? Again. Yeah, you're on mute, Queenie. All right, Novak, let's do it first. We'll wait for Queenie.
Okay.
Left hand side. Okay. Sine 2x times cot x. So what's sine 2x become again?
2 sine x cos x.
2 sine x cos x times, what does cot x become?
1 over tan, so cos over sine.
Yeah, see how you don't use tan because you can see you're using sines and causes here. You've got causes as your answer here. Wouldn't make sense to use tan. But cos over sine, and then
Sine can cut.
what are you left with?
2 cos squared x, yeah.
Easy.
Yes.
B. Andy, let's do B together.
Yeah.
Sine A minus cos A. Okay, what would you do, Andy, when you see such a question? What does your gut instincts tell you to do?
Move the square.
What do you mean by move the square? I don't know what you mean by
Or
move.
square root both sides.
Square root? No, no. That's solving. You're trying to solve. Here, you're proving. So if you're solving, yeah, you're trying to get rid of the squared. Here, you're not really going to be doing that. So when you see this squared, do you have anything else other than square rooting? No?
I don't know.
All right, that's fine. Shania, do you know what to do?
I'm not sure.
But
Expand?
you would expand.
Probably not. I don't know.
Yeah, expand.
Yeah?
So continue. Yep, you might as well continue it now. So what are you going to write? What's your first line?
2 sine A.
No, you mean
What?
sine squared
I mean sine square, sorry.
A. Yep, that's fine. And then 2 times the inside, so that
Yep.
becomes minus 2.
Cos A. Yeah, and then plus cos A square. I mean, yeah.
So just so you guys get that, cos A squared is this, cos squared A is this. Now this one is actually the A being squared, whereas this is actually the whole of cos being squared. And the only reason why we don't put it at the end is because it'll confuse everybody with something like this. So we say it as cos squared A, even though we mean probably all of cos A being squared. Okay.
Okay.
Yep, and then keep an eye on what you want to find. But, yep, what do you know about this and this?
That equals 1.
That does equal to 1. And what do you also know about this guy?
That equals sine 2A.
Doesn't it, right? Because sine 2A is 2 sine A cos A. So therefore, vice versa. 2 sine A cos A becomes sine 2A. But like I said, if you keep looking at the way I'm trying to teach you guys, which is just do it what you would normally do, keep an eye on what you're trying to find, and pretty much the answers are there. I mean, look, it says 1. You'll probably see it. Sine squared and cos squared is 1. Oh, I'm really stuck with this. I don't know what this becomes. Well, it does say sine 2A. Well, yeah, it does become sine 2A. You'll be done. It's a lot easier than trying to just look at this line by itself. So, cool, good job. C. Anouk, you can do C, left hand side. All right, 1. He's probably going to stay as 1 for now. Plus, what about this guy?
It would be cos squared theta minus sine squared theta.
Over.
2 sine theta cos theta.
Now, there's a few ways of solving this. And what are we trying to find, Anouk?
Oh, we're trying to make it equal cos.
Which is what?
1 over 10 or cos over sine.
So keep that in mind. You probably want cos over sine. So look at all this mess. You probably want to get rid of the 2 and the cos at the bottom and so on for the top. All right. So there's a few ways. In fact, I can think of at least 3 different ways of solving this one question. I'm going to show you probably the most unique way. Excuse me. I'm going to show you the most unique way of doing this. What does 1 equal to, Anouk?
Cos squared theta plus sine squared theta.
Yeah, that's a pretty unique way. So instead of changing these two, I'm actually going to change the 1 for cos squared plus sine squared. And then look what happens. What happens to the sine squares?
They go.
Yep. Gone. And then what's cos squared plus cos squared?
2 cos squared theta.
And then? The squared
That equals cos theta.
Could you do like 1 minus sine square theta?
Here?
Yeah.
Yes. But let's talk about that real quick. Hold on. Can I make this one? Oh, wait. Can I change 1 minus sine squared?
Yeah.
Or can I make this one into 1 minus sine squared?
No, can you do 1 minus sine square theta and then
Becomes
you could
cos
do-
squared theta?
Yeah.
Yes, absolutely. So that's another way of doing it. But like I said, there's a lot of different ways. So you could have done 1 minus sine squared becomes cos squared, and then cos squared plus cos squared would still give you 2 cos squared, and you'll end up with this section right here.
Okay.
Good job. There's a lot of different ways, just so you know. Like you could have even changed just sine squared, just this sine squared here, to 1 minus cos squared, and it would have still worked out. Everything else would have worked out. Because minus 1 and this positive 1 would have cancelled, 2 negatives would have made it into a plus, so you would have still ended up with 2 cos squared.
Okay, cool.
Yeah, there's a lot. You don't have to be too strict with your trig proofs, because there's at least, every single question, there's at least 3 ways of doing it. Okay. Let's look at maybe proving this. Okay. Queenie, are you back yet? No, she's disappeared on us, I think. All right. Emily, let's do it together. So, left-hand side equals sine 2a. What are you going to make sine 2a become?
2 sine theta cos A.
Yeah, so if it was theta, you would write theta. If it's a, you write a, so on. On 1 plus
Yes. Cos 2A.
cos squared a. Yeah, so it becomes cos squared minus sine squared a. Yeah, cos 2a is cos squared minus sine squared. Sine 2a is 2 sine a cos a.
Yeah.
All right, tell me, what do you want to do with your next line? The top doesn't change. Let's try to change this 1 again. What does 1 become?
I don't know.
1 equals cos, exactly like what we just did, cos squared a plus sine squared a. And then can you see how these two would cancel out?
Yeah.
Can you do remember that 1 is cos squared plus sine squared?
Yeah.
Yeah. There's a lot of formulas, isn't there?
Yeah.
I understand. On cos squared plus cos squared,
It's 2 cos square A. Yeah.
these guys would cancel, this would cancel, you're left with sine over cos, which equals to the right hand side.
Yeah.
Alright. I might stop our recording there.